Hello and welcome to another video by Emily Learning where we talk about what you need to know for O-level physics. In this video, we'll be talking about what you need to know for the chapter on dynamics. So let's get started. All right, let's take a look at um, the syllabus on dynamics, okay, to see what we need to know. Okay, so we need to be able to apply Newton's law, okay, to describe effect of balanced and unbalanced forces on a body, describe the way in which a force may change the motion of a body, and identify action-reaction pairs acting on two interacting bodies. Okay, and here this says that stating of Newton's law is not required. In other words, they won't ask in the exam, state Newton's first law of motion, state Newton's second law of motion, but they would want you to be able to apply the laws. Okay, all right, so the first law of Newton says the first Newton's law of motion states that, right, an object will continue in its motion in a straight line or be at rest if there is no net force acting on it. So what it actually means um for first law is, let's take a look at this formula. F equals to ma, where F is resultant force, m is mass, and A is acceleration. So if you are talking about the first law, right, what it is trying to say that is that when resultant force is equals to zero, acceleration is equals to zero. So if acceleration is equals to zero, it means that if something is moving in a straight line, it will continue to move in a straight line at constant velocity, okay, when resultant force is zero. If something is not moving, then it will continue to be not moving. That is what first law is talking about. How about second law? So second law simply says that if is not equals to zero, then F will also not be equals to zero, and the resultant force is proportional to the acceleration if mass remains constant. So in other words, it is basically, if you look at it, right, it's basically F equals to ma again, but it's trying to say that when A is not zero, F is not equals to zero, and A and F are proportional to each other if mass is a constant. For the third law, it is saying that for every action, there's a reaction force that acts in its opposite direction. So for example, I have an object here. It has weight, right? So the weight will and this is my ground, my floor, okay? So if this block exerts a force of W on the floor, then this floor will exert an equal plus but opposite force on this block. Okay, and this force that is exerted by this ground or this floor on this block is what we call the normal reaction force. Okay, so this is and so this weight and this normal reaction force are a pair of action reaction forces. Let me give you another example. So now I have this string here, okay, and this is a metal ball. So a metal ball has weight. So this weight will pull on this string here, okay? So why doesn't this string drop off? Well, because there will be an opposite but equal force, okay, which is called tension inside the string. So this string will exert an equal but opposite force on the ball here, okay? So this tension and weight are another pair of action reaction forces. Okay, so that is how I would briefly um, look at these three laws, okay, of Newton's law of motion. Next, let's go on to part B. So they ask us to identify the forces acting on an object and draw free body diagrams representing the forces acting on an object. Okay, and most of it are in two dimensions. In other words, that means they are along the same straight line. They can be in opposite directions, but they are in the same straight line. Okay, or they are parallel to each other. Okay, so basically you need to be able to draw these type of diagrams. Okay, C. Solve problems for a static mass point under the action of three forces for two-dimensional cases. A graphical method would suffice. So for example, so what it meant is, for example, okay, it is draw. This is basically saying that you need to be able to draw a vector diagram. Okay, so for example, I have this object here. So remember this object. There's a weight, right? That is tensional force. Okay, and let's assume that I have this force. So I'm pulling it backwards, okay, in this direction. And the object stays stationary. So I want you to find what is this force here, given that I know T and I know W, or maybe give, okay, so for example, I know T, I know W, I want you to find F. So now they are not they are not parallel to each other, right? These forces are not parallel to each other. So if they are not parallel to each other, we cannot add them out or subtract them, right? So in order to find the resultant force, what we need to do is to draw your vector diagram. So I know that F, W, and T, okay, must cancel each other out. Okay, these forces will cancel each other out because this pendulum is not moving, right? So in other words, right, W, so I'll draw this W, F, and then T. Okay, so they must go in a cycle and return to the same point because the net force is equals to 0. I talked about the drawing of the vector diagram in the video on physical quantities, so you may like to check that out if you want to find out more about drawing of vector diagrams. Okay, so basically what this part is trying to tell you is you need to be able to draw a vector diagram. Okay, so if they are not acting in the forces are not parallel to each other, then you need to draw a vector diagram. So make sure you know how to draw them. Okay, then part D is basically the formula resultant force equals to mass times acceleration. So F equals to ma. Okay, so this is the formula that you need to remember for this chapter. I do have a post where I list all the formulas that you need to know for physics. So this is one of them. If you want to find out what are the other formula that you need to know for physics, for O-level physics, to check out that post. I'll provide a link to read in the description below. Then finally, on this chapter, explain the effects of friction on the motion of a body. Basically, friction opposes motion. Okay, so what it meant is, okay, if my object is moving in this direction here, then the frictional force will be acting in this direction. Okay, so friction always opposes motion. So friction is a force that opposes motion. So okay, if my object is moving upwards, okay, so it's moving upwards, then the direction of the frictional force will be in the opposite direction. Okay, yep, so that's it for the chapter on dynamics. So do check out our other videos to find out what you need to know for other topics. So I'll see you.